So welcome back. So here we are with another problem of purposes. It says maze. Okay, so Pavel loves grid mazes. A grid is a maze. A grid maze is of n cross m rectangle maze where each cell is either empty or a walkthrough. You can go from one cell to another if both of them are empty and have a common side. We cannot go diagonal in direction, so we definitely need to have a common site. Table true, the grid maze with all non-empty cell forming a connected area. Table true a grid maze with Table what Table will do, Table will true a grid maze with all empty cells forming a connected area. That is, you can go from any empty cell to any other. Table doesn't like it when his maze has two little walls. Now, the interesting part comes. He wants to turn exactly k non-empty cell into walls so that all remaining cell is still form a connected area. Okay, so we need to turn exactly k non-empty cells into wall so that all the remaining cell is still form the connected area. Okay, uh, the inputs are given to us. Three integers n and m and k as described earlier. Dot will represent the empty cell and hash will represent a wall. Good. Now, print and lines containing m characters will it will print the grid, which is the solution for this problem. Let's see for this test case. We have a hashtag. Let's make this particular example. Good. What we are doing, we are creating, we are taking this cell and this cell marked as a cross. And again, we can see the area is connected. Earlierly, all these dots are connected. After placing the sign, they are again connected. For this example, still they are connected. Initially also, this entire dots are connected with each other. Um, exactly K, exactly K empty cells have to be converted into a wall. Okay, it means at the end, after uh, marking the colors, we need to have a single connected component, a single connected component. If the dots are equal to k, if the dots are equal to k, then we can place all the k in those dots, and area would be zero for the dots. But that's what we can do if k is equals to the number of dots. Um, Now, in some different case, when we have a dot and a hashtag and k is lesser than the dots, um, we need to somehow place hashtag and place with the dots. Okay, okay. Uh, when I see this example, if I see the one are connected, the one are connected, we can see the one are connected. We should not partition these into two regions. The region still have to be single system only. So it can be it can be like if I take the terminal points, if I take the terminal, or let's say this region has two terminals, this terminal and this terminal, and I make these as cross, and I make these as cross. Uh, uh, these points are not a terminal point, and but if I make x over here, they will be get converted into two components. They will be get converted into two components. These two over here, this cell and this cell, you know, these two are also, I'm going to say, connected. Okay, so, this and this. Okay. But how could we do it? How could we do it? See, uh, when I use a DFS, I go I go in one direction. I go in one direction. Let's say we take the uh, downward path, or basically I'm saying that when I do the DFS, when I do the DFS will be done in a sequential manner. The DFS will be done in a sequential manner. Let's say that it will go from this, then 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 this. How will the DFS will work? Let's say I go the downwards first, then I go the rightwards. Let's say I go the downward, then this direction, then this direction, then this direction. Okay, so it will go all the way to the down. It will go all the way to here. It will go all the way to here. It will go all the way to here. Then when it come back, then it will visit this particular number. So it it follows a pattern. It follows a pattern. It follows a pattern. Cool. When it follows the pattern, it can like when I move forward, the first time I'm moving, I'm going in a the signals are green, and I just go, and I just go away, and I just go away. I'm getting visited each time. I'm getting a non-visited cell each time, and I mark down as visitor. The DFS call is completed, then it will return. Then it will return. Then it will return. The DFS will be completed and then it will turn back. Yeah, so when we have the basic structure or childs, you know, or the children or this particular node, or the children of this particular node, I will visit the first child, then I apply my DFS function, I return and this function call will be completed. This function call will be completed. See, the naive solution could be that uh, when I go, if I mark it as X, if I mark it as X, first child, I marked it X up to K times. And DFS return has not done yet. DFS return has not done yet. DFS return. Like when I use in the visited, I have the visited region and I have the visited region and I am doing the DFS. It will do this, 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 it will do this. But still, we are not sure how to exactly do it, how to exactly what. Let's take this example for a minute. Let's say I call this TFS from here. It will go in upward direction. The TFS call return, then it will go in this direction, then it will go in upward direction, then it will go in this direction. Like my order is up, right, down, left. This is my order. Alright, go right, it will go all the way down to up. Now, this is not allowed, this is not allowed, it will go this, it will go this, then it will come back and it will this. Oh, if I, while going forward, if I mark my color, let's see, uh, different color. I mark my color. I mark my color. I mark my color. Right. I mark. I mark the colors. Now function will return back and we call this. I mark the color. I mark the color. I mark the color. But it will leave. It will leave it. It will partition it into two regions, and that I don't want. I don't want that. Bottlenecks are created that can cause a partition to happen. Bottlenecks are there. Like I need to somehow make sure that I visit, that I mark the color, that I mark the X in the boundary region, in the boundary region. Let's say this is a boundary. It is an internal cell. So I will reframe first. I will mark this. This is also deep, the deep node looking color all the way back. But if I see the visited pattern clearly, this would be visited, uh, this would be visited, this would be visited, this would be visited, this, 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 because this is the visiting pattern. I get to the bottommost point. I get to the bottommost point. Let's say I choose to color the get to the bottommost point and I choose to color it again, 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 again, color it again, color it. So what I noticed is that this, this fellow, this fellow is called at the very last. It means the previous guy, who was the previous guy of this, the previous guy have either made the choice to this or have made, like, before visiting it, this particular number was visited. So if I color this, then I color this, then I color this, then I color this, then I color this. Over here, let's see what was my. We just need to validate this idea. The intuition is coming that it should work. Let's say I have this, and what should be the starting point? Let's say I took a middle way. This time I took a middle way for a better understanding. Let's say we move to the top, then we move to the right. Let's say top movement was there, then the right, then the bottom, and then the left. So that downward movement will happen. Right. And the college is still being made, and this movement will be more than this. And at the end, this. So I will just color it. I will just color from the last guys. I was just coloring from it. And I can see the region is still connected. I can see the region is still connected. So If I can have a path, if I can have a path of drawing, if I have a path, if I have a path in blue and I start coloring from the end, or let's say I start coloring. If I start coloring from the when I just starting the system and I start with the coloring process, it will color, and it will lead to a problem. So I will make sure that the very last node are colored first. The very last node are the colored first. Very last node are the colored first. The very last node are colored because they are the deepest, like the deepest node will be, what is the DFS? The deepest, if I have a graphical structure, the deepest number are visited first. The DFS starts and then go to the deep nodes. Then it will come back. Then it goes. Then it goes here. Then again it comes back. It goes here. Again it comes back. Goes here. Then come back. It goes here. Then this will be, I get started going from this, then this. I think my job should, I think my job should be done. Let's test the logic. What we have just built. Okay, so to keep the order, we will use the stack. Yeah. Uh, what the stack will contain? The stack will go deep inside. The stack will go deep inside, and it will give me the deepest. Uh, 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 it will go in. It will go deep inside, and then it will go deep inside, and then I got a point with me. Then again the DFS call will be there, and again the call will be made, and all the way down to the very deep nodes. Deep mean the last visited. I need the last visited in the stack can be placed at the top of the stack. Okay, so let me just write down the code. So, yeah, I think we can use code. I think we can use this function to write the code. Uh, Let me just take the inputs first of all. Put NLP algorithm. Teacher and here. Now let me make my grid. Let me make my grid first. Cool. It will contain characters, studio, and store. Cool. Let's just quickly get the inputs. Cool. So I will have for what is it was is the inputs is for plus one and GS plus X I. Cool. Um, now Use the stack. Ah, stack can be anything. I will use a stack of pair. Alright, cool. Uh, let's just call the database. Um, let's just take any starting. Good. Let's just take on the start. Start starting x. Starting y. If method of should equal equals to dot sy is equals to 2. Cool. I'll also have to keep a vector positive. Marked as -1 initial. I'll call it this function. Yes. I'll also have to put the test case over there only. Uh, I'm started to call it this function. So this that's that's visit correct. I think also the start. Just keep it above this. Now what will I do? I will simply write this function. Start. I'm visiting a node. Um, will mark it as visit. Cool. Um, I will create a dr array for the neighbors and also DC array for the neighbors. Row for the, let's say, left, right, up, right, up, left, down, right. Okay, so the right would be 0, -1, 0, 1. So columns to 1, 0, -1, 0. Uh, um, so that's all everything. Plus plus. Okay, we don't check. 0 is equal to alpha, so we are of 5. Column will be equals to secrets. This um, this is I need to check if these are valid. This so one so this is and also the visit should be marked as -1 and also there should be a dot. Now what will I do? Mark the this function. Sorry, I'll call the this function. Uh, at the very end. I will put the node into the center. So let's push RC pull. Uh, I think it should work. Okay, so let's just create a um, also that we initialize your answer is initialized. Now I will just start copying from the stack only the top K. So while K small noise still dot stack should also contain something to come out. So top back and how to be top and basically I will mark it as X. So I have marked it as X and I have to print it. Should I use a, I don't get what want to do. This is not necessary, but let's say. Good. I have to uh, see if the stack dot size is equals to k, then all will be colored in, all will be marked as X. But let's say I don't have anything, then these are initialized as a -1, minus 2, origin. It's single connected, then it's a single connected system. Only then I'm doing this DFS for this tool. And this DFS is called create. I think should should do some so there are some errors. But for it to it should be okay. Now what error is there? Okay. Only one is getting it's printing it appear. This. So the components are connected, right? Components are connected. Cool. The components are still connected. I hope it works. What works? Yeah. Sorry for the interruption. Again, it's coming. Okay. Okay, it's wrong on this one. Uh, let we have to provide a space between these, I guess. I have to provide space, I guess. So still a noise. I guess. What it actually means is mm, cool. Like these all are uh, let me just think. Cool. So it got accepted. We know that a stack contains the first in, last in, first out principle. So, what we have to do, we have to basically put into the stack why before visiting the child. So we have to put the stack over here instead of this, and we don't. Yeah, cool. That was the solution. I hope you understand the solution. Thank you. Keep learning. Bye.